The next video in assignment problem is traveling salesman problem, where in a traveling salesman problem, the salesman want to travel from city to city, from the cities to the cities. He has to travel to all the cities from his home city and reach back to home city. That is, he has to travel once and only once to other cities. That is the main condition in your traveling salesman problem. If he didn't did that, he got any broken route, we have to make it as an unbroken route, and we are going to find out the traveling salesman problem. So here, what is the first step? Here you can notice that there is a condition, he didn't reach the places to the respective cities. That means A to A, B to B, C to C, D to D and E to E. That means he didn't have any scope to go to the respective cities. There you are going to have infinity or dash. Now we are moving on to the first step of your Hungarian method, that is row reduction. In the row reduction, the first value, that is 1. In the first row, the value of 1 you are going to reduce from each and every value of that row. Infinity will be the same. The diagonals, you are going to get your infinity as it is. Now 2 minus 1, 1, 5 minus 1, 4, 8 minus 1, 7 and 1 minus 1, 0. Likewise, you are going to do for all the rows. You are going to get the row reduction matrix like this. Now, for the row reduction matrix, you are going to do the column reduction. So, where the column reduction, in the first column you have 0, you are going to write it as it is. In the second column is also having 0, you are going to write is as it is. In the third column, there is only value of least one value. That value of 1 you are going to reduce. So 4 minus 1, 3, 1 minus 1, 0, infinity will be as it is, 3 minus 1, 2 and 1 minus 1, 0. And the and the fourth and fifth columns are having zeros. You are going to write it as it is. Now we are moving on to the step 3, that is assigning zeros, where in assigning zeros we are going to write the copy of column reduction matrix where you are going to give assignment. So in the first row there is only one single zero which should be assigned. No zero will be there in that column. We are going to cancel the zeros in that column. So in the second row there is only one single zero which should be assigned and no zero will be there in that column. We are going to cancel this zero. In the third row, there is only one single zero which should be assigned, and in the fourth row, only one single zero, and in the fifth row, only one single zero. Now, assignment has been done. Now, you got an optimal solution and you have to check either it is a broken route or unbroken route. How we are going to check that? See, here we have the from the city to the city. So, what are the cities here? From the cities A to A, B, C, D, E and to the cities A, B, C, D, E. We are going to have the assignment as A to E, B to C, C to D, D to B and E to A. So, either you got a broken route or unbroken route, you have to check. So, here A to E, he has been gone. From E to A, see, it's a broken route. He didn't reach the places B, C and D. That's why it is a broken route. Now we have to make it as an unbroken route by taking the next least value of your matrix after 0. What is the next least value in this matrix? It is 1. We are going to give allocation or else assignment to 1 next. Okay. Now we are going to write the same copy of this matrix without assignments. So I have been telling you that it's a broken route. He didn't reach the places B, C and D, and we have to select the next least non-zero element from the matrix, that is 1. Instead of giving assignment allocation to 0, give to 1. I have been written the copy of this matrix without assignment. Now I have told you to give the assignment to 1, not to 0. So this is going to be assigned, and when the assignment is done in the row, no 0 will be there in that column. This 0 will be cancelled. Now in the second row, there are 2 zeros. Skip that row. In the third row, there is only one single 0 which should be assigned. No 0 is there in that column to cancel. Now in the fourth row, I already told you to give assignment to 1, no? That's why I give assignment to 1. And in the fifth row, there is only one single 0 which should be assigned. No, there is only one single 0 which should be assigned, and no 0 will be there in that column. Now we are moving on to the column allocation. Whereas in the column allocation, already you have first column. In the second column, we are going to have allocation here already. And in the third column, we are going to give assignment here, and no 0 will be there in that column. Cancel. Now assignment has been done like this. So here A to B, B to C, C to D, D to E and E to A. Now either it is a broken root or unbroken root, you have to check here. So A to B, B to C, C to D, D to E and E to A. It's a unbroken root. He reaches all the cities from the home city to home city. And you are going to find out the value of Z by taking the values from the given question. That means from A to B, what is the value here in the question? That is 2. Likewise, you are going to find out the remaining values, and you got the value of Z as 15. Thank you.